Boing, 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 boing. Hey guys, it's Nick, and today we're going to be doing some dynamics. So I'm sorry for my absence for the past few days. I've been busy, I lost something, but I'm back. Um, and yeah, I hope you're as excited as I am, because I love physics. Okay, now the first question, right? It talks about two balls colliding along a straight line PQ and then rebounding at angles this and this to PQ. The first question is to calculate the component of the final momentum of ball Y in the direction perpendicular to line PQ. So if we were to illustrate this, right, 27 degrees, 3.7 meters per second, that's the velocity of the ball. So this arrow represents the velocity of the ball in that direction. The mass is a scalar quantity which we do not worry about, and they want the momentum perpendicular to PQ. That would just be the vertical component of the momentum, right? So a conceptual way of explaining this would be this component and this component give you a component of this 27 degrees uh, about the horizontal component. So this is like an average formed, not an average, but this is like a product of these two, okay? And they want us to find this. So first we start by finding the vertical component of speed, right? So this is our resultant speed into sine 27 uh, into sine 27. And if you want me to explain it, this is our hypotenuse 3.7, right? And this is our 27 degrees, and this is the way the ball is moving, by the way. And we need to find this bit, and sine theta is equal to, and sine is equal to the opposite side by the hypotenuse. We have the hypotenuse and we have the sine theta value. So when we bring the hypotenuse up to find the opposite side, we get this multiplying thing. Sorry if I'm explaining too in depth, I just want everyone to understand. So 3.7 into sine 27 gives us an answer of 1.68 meters per second. That's our speed vertically. Now how do we get a vertical momentum out of this, right? That's what they want. Momentum in the direction perpendicular to line PQ. Same thing, vertical. So we know that momentum is equal to mass into velocity. And if the velocity is vertical, that will give us a vertical momentum. The mass is a scalar quantity, so it doesn't have a direction. So we can't have the mass being vertical too. But ideally, to get a vertical value x, everything that makes up of x, like y into z into a, they would need to be vertical too. In kinematics, this is more studied. Now, here, 1.68 into 0.25, right? That's the mass of the ball. So that gives us a value of 0.42 Newton seconds. Also, please don't get confused by Newton seconds, okay? Momentum can equal two things. Momentum can be mass into velocity, right? Mass is kg, velocity is meters a second. So these are the base units of that. While momentum can also equal, the change in momentum rather could also equal force into time, right? Force is kg meter per second square and time is second. So that gives you a value of kg meter per second power minus 1. So you can see that both of them equal momentum, and also force and time is also just Newton seconds, which is what this is. So if you see this, do not get scared, okay? it's the same thing. Now let's move onward. So by considering the component of the final momentum of each ball in the direction perpendicular to line PQ, calculate the mass. So the mass of z isn't given, right? It's not given and we need to find it. How do we do this? First, momentum before is equal to the momentum after. This was a terrible notation, don't remember B equals A. But the momentum before is equal to the momentum after. But they all need to be in the same direction. For example, the vertical momentum before, the sum of vertical momentums before will equal the sum of vertical momentums after. The sum of horizontal momentums before will equal this horizontal component, cos 27 into 3.7, and this horizontal component, cos 44 into 5.5. So there are so many ways of solving this, okay? But the way we're going to do it is by considering the vertical component, because that's what they've asked us to find. They're kind of helping us in a way. So we know that this vertical component is 0.42. We can say Newton seconds, we can say many things. Now, this vertical component, what is that? It's going to be same thing, right? So we're going to say sine 44 into 5.5 into the mass. Do we know the mass? No. But what we do know is this whole thing is momentum, and this whole thing is momentum. But this is an important thing. Momentum is scalar, meaning this is negative, okay? This is very important. Now, we can consider the vertical component of momentum here, and it is clearly shown that it's 0. Why is it 0? Because this arrow represents speed. Yes? Speed. There is this speed initially which they have not given us because it's irrelevant to the question, and there is no speed for this ball. So already you know that this ball's overall momentum component is 0. So this is 0, this is 0, this is 0, right? And this has a horizontal component only. It does not have a vertical component at all, right? It's in the direction of thing. So if it was slightly this way, then we could resolve it into components. But there is no theta. You can see clearly that here, while there is a theta angle, here there is no angle, right? It is in the direction of movement. So, So, let's form an equation. We know that 0.42 plus, let me simplify this, sine 44 into 5.5 with a minus sign. So we can say plus minus 3.82 into mz. This is the sum of momentum after the collision vertically, right? Equals the sum of momentum before the collision. We're only considering vertical momentum. This is important. This is 0. We have formed a one variable equation. Give yourself a high five. Can you even give yourself? Yes, you can. Okay. 0.42 plus, no, we say minus 3.82 into m2 is equal to 0. mz, sorry. Right? Yes. So, now we say, we bring this to that side and we can say 0 point minus 0.42 divided by minus 3.82 is equal to mz, right? 0.42 divided by 3.82. This gives us a value of, by the way, when you type this in the calculator, you'll get 1099. Are you going to give your answer like this? No, you have to round up, okay? 0.11. That's our final answer, and that's the mass of the ball. I hope you understood this. If not, please ask your questions in the comments. So let me just go over what we did all over again, okay? I won't do it, I'll just explain it. So, if you take any direction, this direction, this direction, right, the momentum here plus the momentum here will be equal to the momentum here, sorry, momentum in that same angle here, here, example, but you have to consider the sign and all, so it's a bit complicated, but we have it very simple, right? We're just saying the momentum here, right, the momentum this way or this way, regardless, should be equal to the momentum this way and this way. This question is kind of helping us, it's telling us what to do, it's hinting, okay? So it's saying, hey, 0.42 is this side, this is a scalar, I mean a vector quantity, so minus opposite direction, perfect 180 degrees, this is negative, okay? So minus this component of momentum, which is formed using an equation relating vertical velocity and mass, right? That should be equal to this vertical component of momentum, which is 0. No matter what direction we take, it's 0. There is no vertical component anywhere. It's very important to identify that there's only one speed, and that's horizontally, so that doesn't create any vertical component at all. So that's what we did there. I hope you understood. If you can grasp this, you will be fine. I mean, it's a simple thing, okay? All these questions are relatively easy, and I believe in you. So okay, so our last question is this: during the collision, the average force exerted on y by f is y by y on y by z is Fy. So y is exerting a force on z, that's Fy, and the average force exerted on z by y is Fz, right? So z also exerts a force on y in the collision. So when they collide, right, y and z, this guy exerts a force, this guy exerts a force. Compare the magnitudes and directions of these two forces. Okay. So also when they say numerical values are not required, the directions are not, you're not going to say something like 180 degrees to this side. It's not going to be like that, okay? You have to talk purely in words. I mean, that's what they expect. So this is just the application of Newton's third law. A force is acting, right? A force is acting on ball Z that will provide an equal and opposite force on ball Y. It's like when you're pushing a door this way, you're exerting a force on the door, but when you push it, you also move back a bit. That's the door exerting a force on you. This is an application of Newton's third law. So this is something you need to remember. They're testing your knowledge on Newton's third law. So the magnitudes are equal, okay? An equal and opposite reaction. When force is exerted on the body, it produces an equal and opposite reaction to oppose that force. So equal, but since this force is on ball Z and ball Z is exerting this exact force opposite in perfect 180 degree angle to ball Y, we're going to say opposite. And that's it. This is actually your homework, okay? It's a 1 mark question, and yeah, so this is homework. Please do it right now or sometime in the evening or afternoon or whenever you want to, but if I get 2 comments doing this, I'll be very happy, okay? In my next video, I will dedicate those 2 comments, okay? Thank you for watching, and I hope you're happy, and then I hope you do well in your physics exams. Goodbye.